Lesson 6-9, Scientific Notation. And in this lesson, you learn to write numbers in scientific notation. Why is it important? Because scientific notation allows you to express the distances between planets. So let's take a look at this application in geology. Dr. William Rose, a geologist, specializes in the study of volcanoes and their effect on the atmosphere. He and his team study the Augustine volcano about 280 kilometers from Anchorage, Alaska. The Augustine volcano uh, erupted twice in 1986, once in March 27, then again on April 4th. Even though these eruptions were relatively small, on March 27th and 28th, the volcano produced 75 million metric tons of fallout per day. The individual particles in the fallout were very small. The diameter of the particle was 0.000022 of a meter. Okay, so what does it have to do with our lesson? Let's find out. So it's it's easy to make mistakes when computing with small numbers such as 0.000022 and large numbers such as 75 million. People who deal regularly with such numbers use what we call scientific notation. Okay, and what is scientific notation? Numbers expressed in scientific notation are written as a product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So let's take a look at this definition. So it has to be written as a product of a factor and a power of 10. That's one condition. And the factor must be greater than or equal to 1. So your factor should be greater than or equal to 1. Okay? But less than 10. Okay? So it cannot be less than 1. It cannot be greater than 10. Okay? So why is this called scientific notation? Probably guessed it, because most of the time scientists use this. Okay? People who deal with big numbers are mostly scientists. Big numbers and very small numbers, and that's why it's called scientific notation. So let's apply what we know in the definition. So to write a large positive or negative number in scientific notation, move the decimal point to the right of the leftmost digit and multiply this by a power of 10. Okay. Again, to write a large positive or negative number in scientific notation, move the decimal point to the right of the leftmost digit and multiply this power by a number by a power of 10. Again, to find the power of 10, count the number of places you move the decimal point. Let's see how this is applied. Write each number in scientific notation, 687,000. Again, our definition says that to be able to make it for a number to be in scientific notation, it has to be a product of a factor and a power of 10, and the factor must be greater than or equal to 1 and less than 10. So in this case, 687,000 can be written as 6.87 times 10 to the 5th power. What happened there? Move the decimal point 5 spaces to the left, multiply by 5. So what we did is this. So in a 687,000, the decimal point would be to the rightmost. Okay, and then we simply moved it so that the factor, okay, is greater than or equal to 1 and less than 10. So 6.87, how many times did you move that to make it 6.87? And that's 5 times, and that's how you got 5 right there. Okay? Okay, let's take a look at example 1b. Okay? Example 1b. You have 50 million. You want to make it into you want to express this number as in scientific notation. So what do? You have 5. 50 million is equal to 5 times 10 to the 7th power. Basically, move the decimal point 7 places to the left and multiply by 10 to the 7th power. Again, what happened here was that the decimal point is to the very right. So we simply moved it so that you will have a factor that is greater than 1, but greater than or equal to 1, but less than 10. So 1, 2, 3, 4, 5, 6, 7. Since we move the decimal point 7 spaces to the left, okay, from the right, okay, this is 5 times 10 to the 7th power. Okay, now we cannot say, or we cannot put this as 50 times 10 to the 6th power. Why not? Because 50 is greater than 10. Okay, it has to be less than 10, that's why it's 5. So this is not in scientific notation right here. Okay, so this is not in scientific notation, so we cannot do this. Okay, let's take a look at the next example. Before we do that, to write a small positive number in scientific notation, we need to move the decimal point to the right of the first non-zero digit. Okay, remember that in the in example number 1, we move the decimal to the left because it is a large positive or negative number. In this case, since it's a small positive number in scientific notation, we move the decimal point to the right instead of to the left of the first non-zero digit, and this becomes important too. The first non-zero digit, and multiply this number by a power of 10. Okay, before that, remember that 10 to the negative n is equal to 1 over 10 to the n. That is the rules of exponents, rules of negative exponents. So count the number of places you move the decimal point and use the negative of that total as the exponent of 10. This becomes more clear as we go through the example. Okay, you can refer back to 4-9 if you want to review negative exponents. So we want to write 0.00003576 in scientific notation, and it is written as 3.576 times 10 to the negative 6. Why is that? Because opposite of what we did in example 1, instead of moving it to the left, we move it to the right. Now look, we want to find a number, okay, a factor that is greater than or equal to 1 but less than 10. So we move that decimal 1, 2, 3, 4, 5, 6, which will make it 3.576. Okay, and since we move that decimal 6 spaces to the right, okay, we have 3.576, and instead of a positive exponent, it becomes a negative exponent. Okay, so if we move that, let me erase that thing because there you go. So you move that 6 spaces to the right, becomes negative 6. Okay, and then we multiply it by 10 to the negative 6. Why is that? Because if you notice, okay, 10 to the negative 6 is 1 over 1 million. Okay, and if I put 3.7, if we do 3.576 all over 1 million, that would be the decimal right there. Okay, let's take a look at the next example. Write each number in standard form. Remember, standard form is simply putting the number back the way we normally read it. Okay, so we have 8.495 times 10 to the 5th power is in scientific notation. So we want to make this standard form. So what do we do? Okay, since it's a positive exponent, okay, we move the decimal 5 spaces to the right. So 8.495 times 100,000, or simply move the decimal 5 spaces to the right. Okay, so this becomes 849,500. Okay, moving it 5 spaces to the right will give you that number. In letter B, we'd look at the negative exponent, 3.08 times 10 to the negative 4. Since this is a negative exponent, instead of moving it to the right, in the case of example A, we're moving it to the left this time, 4 spaces to the left. Or we simply multiply this by 1 over 10 to the 4th power. Sorry, 1 over 10 and to the 4th power, because that's following the rules of negative exponents, 10 to the negative 4. Sorry, let me redo that. Okay, 10 to the negative 4 is equal to 1 over 10 to the fourth power. Okay, so multiplying 3.08 times 1 over 10 to the fourth is simply the same as moving, okay, multiplying it by 1 over 10,000, or moving the decimal 4 spaces to the left. Okay, so 1 over 10,000 is the same as 0.0001. Okay, and then or the same as moving it 4 spaces to the left, so you end up with 0.000308. So all you need to do here is simply do this. If you have 10 to the negative fourth, okay, you simply need to write 3.08 and move it 4 spaces to the left. 1, 2, 3, 4. Put that decimal there and simply add zeros to the spaces. So you have 0.00308, exactly what we have here. Okay, so this can be a little bit confusing if you don't know what to do with the positive exponent and with the negative exponent. With the positive exponent, you need to move it to the right to make it standard form. In the negative exponent, you need to move it to the left to make it standard form. Okay, before we go to the last example, the keyword for this one would be geology. Okay, so the keyword for this lesson, or the secret word, will be geology. It should be included in your summary, the word geology. To go to the last example, you can compare and order numbers in scientific notation. First, compare the exponents. Okay, with positive numbers, any number with a greater exponent is greater. With the exponents, if the exponents are the same, compare the numbers. Again, you can compare order numbers in scientific notations. You need to first compare the exponents. With positive numbers, any number with a greater exponent obviously will be greater, and if the exponents are the same, then we simply compare the numbers, or the base. Okay, so the diameter in Venus is 1.208 times 10 to the fourth kilometers. The diameter of the Earth is 1.276 times 10 to the fourth kilometers, and the diameter of Mars is 6.79 times 10 to the third kilometers. Rank these planets by diameter from least to greatest. Okay, so follow what we learned right here. So what do? Okay, we look at 1.208 times 10 to the fourth is less than 1.276 times 10 to the fourth. If you notice, Venus will have the same, and Earth will have the same exponent, which is 10 to the fourth. Okay, and a little FYI, Venus is considered to be the twin planet of Earth. Okay, that's what they thought of before, but in terms of size, but that's where the comparison ends. Okay, so you have 1.208, which is the diameter of Venus, times 10 to the fourth, and the diameter of Earth 1.276 and 10 to the fourth. Why is it less? Because now, since the powers, or the base and the exponents, are the same, the powers are the same, we simply compare the decimals. That's 1, that's 1, and we compare from left to right. That's 2, that's 2. Moving on, that's a 0, and this is a 7. So this is where now we start to find out that it's less, because that digit is a 0, this digit is a 7, and 0 is always less than 7. So we know that 1.208 times 10 to the fourth is less than 1.276 times 10 to the fourth. Okay, so basically the exponent is the same, and that's the reason why it's less than. So Venus is smaller than Earth, we know that. 6.79 times 10 to the third is less than 1.208 times 10 to the fourth, because just by looking at the exponents, this is 10 to the third power and 10 to the fourth power, we know that Mars would be a lot smaller than Venus. Okay, so therefore the rank from least to greatest would be Mars, Venus, and Earth. Okay, and that is how you use standard notation, and converting it back to scientific notation and converting it to standard form. And that's the end of our lesson. Thank you for watching.